Hello everyone, welcome to my channel Masada and thank you for liking my videos. Today I am going to take second lecture on quadratic equation. In the previous lecture I did cover basics of quadratic equations, and in this lecture today I am going to do symmetric functions of roots, then transformation of quadratic equations, and then quadratic identity, and then for condition for common roots where one root is common, and then second is when both the roots are common, and in the end I am doing condition on sign of roots. So let's start. Symmetric function of roots. What we do in this, if a quadratic equation has root alpha and beta are roots, then function of alpha beta, if it is equal to function of beta alpha, then it is called symmetric. Means what? If you interchange alpha beta, expression remains same, that is called symmetric function of roots. So let us take example like alpha beta square plus beta alpha square. This is symmetric function of roots. Why? Because in place of alpha if you put beta, it becomes beta alpha square and alpha beta square, both are same, right? So this is symmetric. So some of the questions will be, a function will be given and then say it will say root is alpha beta, then find alpha beta square plus beta alpha square plus 2 alpha beta. How to do that? You will be finding alpha plus beta, that is minus b by a, alpha beta, that is c by a, right? And put it here. So let's take this example only and find the value. X square plus 5x plus 2 equal to 0. And then question is alpha beta are roots. Find this alpha beta square beta alpha square plus 2 alpha beta. How can we do that? This can be simplified. Take alpha beta common, then it becomes alpha plus beta, and this is 2 alpha beta, right? And here from this equation, what is alpha plus beta? Alpha plus beta is equal to minus 5. Alpha beta is equal to, that is minus b by a, c by a. Now put it here. So this is equal to 2 into minus 5 plus 2 into alpha beta is 2, that is minus 10 plus 4 minus 6. This is your answer, right? This is very small thing. Moving to next is transformation of quadratic equation. So what is that? A quadratic equation will be given and we know its root, then we need to find quadratic equation whose roots are related to the previous one. It's kind of this. Ax square plus bx plus c equal to 0 has roots alpha comma beta. Find the equation whose roots are alpha plus 2 comma beta plus 2. And second question is roots are 1 by alpha and 1 by beta. So how to do it? We will divide this into two methods, right? One we already know, second we will be learning today. Method 1. So if I know roots alpha plus 2 beta plus 2, sum will be alpha plus beta plus 4, right? And product will be alpha plus 2 into beta plus 2, which is alpha beta plus 2 times alpha plus beta plus 4, right? Find alpha plus beta from this equation, put it here, find alpha plus beta, so you can find sum and product, and then use which formula? X square minus x into sum plus product is equal to 0. Put all those values and you get the answer. For that you need to find sum and product, and you need to find sum of root and product root from this one, right? Second method is easier one. Easier means it's less time consuming, but this works only when roots are in symmetric format. See, alpha plus 2 and beta plus 2, it's not beta plus 3. So alpha plus 2 beta plus 2, it is 1 by alpha, it is 1 by beta. So similar type of roots are there. Then we can apply this method to what we do. Alpha plus 2, right, is the new root, right? So I can say alpha plus 2 is equal to, name this is x, okay? So alpha is what? Alpha is x minus 2. Now alpha is root of this equation, so it is a alpha square b alpha plus c equal to 0. Now alpha is x minus 2, so a x minus 2 plus b x minus 2 plus c equal to 0. Here square it is. So this is what? This is the equation which will be giving us root alpha plus 2 and beta plus 2. So what I did, in place of x I put x minus 2. So what I will be doing, whatever the root is, name it x, find alpha, put it back in the equation and get the answer. So let's take an example to see this. Okay, so x square plus 5x plus 2 equal to 0. This is the quadratic equation. Its roots are alpha beta. Question is find equation alpha plus 2 comma beta plus 2. What we will be doing? So alpha plus 2 is equal to x, alpha is equal to x minus 2. So replace each x by x minus 2. So it becomes, what is the answer? Answer is this one, x minus 2 whole square plus 5 into x minus 2 plus 2 equal to 0. So if you simplify it, it is x square minus 4x plus 4 plus 5x minus 10 plus 2 equal to 0. So it is x square plus x minus 4 equal to 0. This is your answer. Let us take one more example. Second example is when 1 by alpha, 1 by beta. So what I will be doing, I will be writing 1 by alpha as x. So this means alpha is equal to 1 by x. Now you can replace x by 1 by x because alpha is root, so 1 by x will be root, so 1 by x put here. So it becomes 1 by x square plus 5 into 1 by x plus 2 equal to 0. So it is 1 plus 5x plus 2x square equal to 0. So you can also observe one thing, that is if ax square plus bx plus c equal to 0 has root alpha beta, this means cx square plus bx plus a equal to 0 has root 1 by alpha 1 by beta. You can observe it here, right? So this is how we will be transforming equations, and what we learned here in quadratic, it can be applied for cubic polynomial equation as well as nth-degree polynomial equation. So let's write one cubic polynomial equation. This is the cubic polynomial equation. Its roots are alpha, beta and gamma. We need to find equation whose roots are alpha minus 1, beta minus 1 and gamma minus 1. So what I will be doing, I will be using transformation of quadratic equation. So how we do that? Alpha minus 1 is equal to x, alpha is equal to 1 plus x. So replace x by 1 plus x and get the answer. So this will become 2 times x plus 1 whole cube plus 7 x plus 1 whole square minus 4 into x plus 1 plus 3 equal to 0. Simplify it and then you can get the cubic equation whose roots are alpha minus 1, beta minus 1 and gamma minus 1. We will be seeing more usage of this one later on when we do cubic polynomial equation. Okay, so let's move ahead. Next is quadratic identity. So we know what is quadratic equation. Quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0. It has two roots alpha and beta, right? It can be real, it can be complex. So what is quadratic identity? Identity is one which is true for all values of x. So quadratic identity is what? Ax square plus bx plus c equal to 0 when it is satisfied by all values of x, with only not alpha and beta, like alpha beta root here in the previous case quadratic equation. A alpha square plus b alpha plus c will be 0, right? Alpha satisfies and beta satisfies, right? Here it says not only alpha beta, it will be satisfied by all values of x. Such is called quadratic identity. When it is possible, we know quadratic equation has only two roots, it is quadratic. So how can it be satisfied by more than 2, right? So this is only possible when a is 0, b is 0 and c is 0, then it is true. See that 0 into x square plus 0 into x plus 0 is equal to 0. Put x equal to 1, it satisfies. Put x equal to 2, it satisfies. Put x equal to 3, it satisfies. So, it satisfies all values of x. So, when it is satisfied by all values of x, it is identity. So, what is the condition? Ax square plus bx plus c equal to 0 is identity if a is equal to b is equal to c is equal to 0. Right. Sometime it will be asked the quadratic equation has 3 roots, right? A quadratic equation can have only 2 roots. If it has 3 roots, means it is not your usual quadratic equation, it is actually this situation where a, b, c 0, right? This means if it is saying 3 roots, this means it is actually saying infinite roots, it is about quadratic identity. So, let us take one example to see what type of question will be asked. So, question is if this a be an identity and x, then find the values of a. So, how to solve this one? If it is identity means what? This term is equal to 0 as well as this term is equal to 0 as well as this term is equal to 0, right. So, all should be 0. This means a square minus 1 equal to 0, a minus 1 equal to 0, a square minus 4a plus 3 equal to 0. So, this is a plus 1 into a minus 1 equal to 0. This means a is equal to plus minus 1. From here a is equal to 1. From here if you do it, it is a minus 1 into a minus 3 equal to 0. A is equal to 1 and 3. So, I see 1 is common in 3. So, a equal to 1 will make it identity. Put a equal to 1, it is 0x square, 0x plus 0 equal to 0. So, this is value of a for which this quadratic becomes quadratic identity, right. So, moving next. Next is condition of common roots. So, first situation is one common root. There are two quadratic, this is a. So, two quadratic equation a1 x square plus b1 x plus c1 equal to 0 and a2 x square plus b2 x plus c2 equal to 0. Two quadratic equations are given and it says there is one root common. So, what should be relation between a1 b1 c1 a2 b2 c2, right. So, what to do? Let us start with assuming common root is alpha. This means what? Let alpha be common root, means alpha will satisfy first one as well as second quadratic, right. So, this means a1 alpha square plus b1 alpha plus c1 equal to 0 as well as a2 alpha square plus b2 alpha plus c2 equal to 0, right. Compare this with this one, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. How do we solve it? You remember that one cross multiplication method, that is what we used to do. It is b1 c1 a1 b1 and then b2 c2 a2 b2 and then it like this one, cross multiply cross multiply cross multiply, right. This is x, this is y and this is 1. I see in place of x it is alpha square, y it is alpha. So, it will be alpha square by it is b1 c2, b1 c2 minus b2 c1 alpha by it is c1 a2 minus a2 c1 and then 1 by a1 b2 minus a2 b1, right. From this we can find the relation, right. Alpha square will become what? This will come here. So, it is b1 c2 minus b1 b2 c1 by a1 b2 minus a2 b1 and alpha will be how? When you bring it here, that is c1 a2 minus this is a1 c2 a1 c2, right, divide by a1 b2 minus a2 b1, correct. Now what I see, the alpha is this, alpha square is this. This means what? This square is equal to this one, right? So write it. This is the answer. C1 A2 minus A1 C2 divided by A1 B2 minus A2 B1 is equal to B1 C2 minus B2 C1 by A1 B2 minus A2 B1. Here this will be square, right? Now you simplify it and you get the condition. You bring this term this side. So what will become? It is C1 A2 minus A1 C2 whole square is equal to, if you come this side, it is A1 B2 minus A2 B1 whole square. One term will cancel out, it will become A1 B2 minus A2 B1 and then B1 C2 minus B2 C1. This is your answer. Correct? So how to remember? We will remember like this one. A1 B1 C1 A1 A2 B2 C2 A2. It is A1 B2 minus A2 B1 A1 B2 minus A2 B1 into B1 C2 minus B2 C1 is equal to C1 A2 minus C2 A1 and last you put square, right? This is how, if you remember, it will not be difficult, right? So this derivation what I did here, which is so lengthy, does not help us to solve a question, but in maths what we do, unless we know how, it is meaningless to solve a question, right? So we are actually getting the idea how this condition came. Once you go through derivation, it clarifies the things, right? So that's why we will always be doing the derivation, even though it does not help. So derivation is for one time. So one time you saw it, never revise it. So whatever you are writing as derivation in your notebook, you are not supposed to revise it again and again. It is just for one time. What you need to remember, you need to remember the formula and you need to remember how to remember the formula, right? You don't need to remember the derivation. So let's take one question on this and then we will be moving to second situation when both the roots are common. Find alpha so that x square minus 3x plus 2 equal to 0 is one root common with this, right? So one root common means what? We need to use that condition, correct? So what is that condition? I write like this one, A1 B1 C1 A1 then A2 B2 C2 A2 and then you remember cross multiply, that is A1 B2 minus A2 B1 into, then this is B1 C2 minus B2 C1 is equal to, then it is C1 A2 minus C2 A1 whole square, right? This is the condition. So this means I don't remember this one, I remember this, so I will be using this one here. So how to do it? That is A1 is 1 minus 3 2 1 and this is 1 alpha 4 1. Now this is alpha plus 3 like this one, alpha minus 3 is plus 3, this into, then minus 3 into 4 minus 12, 2 alpha with a minus and minus 2 alpha is equal to 2 minus 4, that is minus 2 square. You need to simplify it. So how to solve this? So take the minus 2 common, this is alpha plus 3 into alpha plus 6 minus 2 here and 4 here, right? So bring minus 2 this side, this is alpha square plus 9 alpha plus 18 is equal to minus 2. Alpha square plus 9 alpha plus 20 equal to 0. So alpha plus 5 into alpha plus 4 equal to 0. Alpha is equal to minus 5 minus 4, right? This is using the method. So this method will work when for any equation, right? But I have knowingly taken the question as one equation is this, so that I can teach you more thing in one question. It is x square minus 3x plus 2 equal to 0, right? So what are the root of x square minus 3x plus 2 equal to 0? This is method 2, right, which is easier. Roots are 1 and 2. This works only when you can find roots easily, right? This means it has root 1 and 2 and it says one root is common, either 1 is common or 2 is common. If 1 is common, if 1 is common root, right? This means what? 1 will satisfy it, so it is 1 plus alpha plus 4 equal to 0. Alpha is equal to minus 5, right? If 2 is common root, 2 is common, means what? 2 will satisfy it, it is 2 square 4 plus 2 alpha plus 4 equal to 0. Alpha is equal to minus 4. See, minus 4 minus 5. It is same as answer from the previous method, right? So I think you understood how to solve questions where one root is common. Move to situations when both the roots are common. So if both the roots are common, then let alpha beta be the common roots. If alpha beta be roots of this one, this means what is alpha plus beta? That is minus b1 by a1. And what is alpha beta? That is c1 by a1. And same way alpha beta is root of this one also. This means what? Alpha plus beta is equal to minus b2 by a2, and alpha beta is equal to c2 by a2. So this means this is equal to this one. So I can write b1 by a1 is equal to b2 by a2, right? Can I say this is a1 by a2 is equal to b1 by b2? Then this c1 by a1 will be equal to c2 by a2. c1 by a1 will be equal to c2 by a2. Again a1 by a2 will be equal to c1 by c2. This means what? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is condition for both the roots common. Find x square plus x plus 1 equal to 0 has one root common with this. Then find alpha and beta where alpha and beta are. So if alpha and beta are real, now if you think like that, it is one common root, so you will be applying that formula a1 b2 minus a2 b1 into b1 c2 minus b2 c1 is equal to c1 a2 minus c2 a1 whole square. Then you did mistake. This was a tricky question. How does we will be doing it? I see x square plus x plus 1 equal to 0. If you look at its root will be what? Its root will be imaginary. So root will be p plus iq, then other will be p minus iq, right? I am not going to find it. You can very easily find the value also. Okay, this will be, root will be like this one, minus 1 by 2 plus root 3 by 2i and minus 1 by 2 minus root 3 by 2i, right? I am not looking here, I am not going there. I am just saying if it has imaginary root, because d is less than 0, root will be, one root will be p plus iq, then other will be p minus iq, they will be conjugate. Now if p plus iq is root of this one and I see alpha beta are real, this means what? P minus iq will also be root, because we know if p plus iq is root of this equation, means what? Conjugate is also root. This means actually not one root but both the roots are common. If both the roots are common, what we will be applying? We will be applying a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That is 1 by alpha is equal to 1 by beta is equal to 1 by 3. If you solve it, alpha is equal to 3 and beta is equal to 3. Now moving to next theory. Next is sine of roots of quadratic equation. So ax square plus bx plus c equal to 0, a quadratic equation is given, it will say both the roots positive. Sometimes they will say both the roots negative, sometimes they will say one positive, one root negative. So what's its condition on a, b, c? So let's start with both the roots positive. When both the roots are positive, means what? Alpha positive, beta positive. So what will be d? D will be, roots are real, right? When I say positive means what? Real. So d should be greater than equal to 0, first condition. Second is if alpha beta both are positive, what is sum of root? It should be positive, that is minus b by a should be positive. Third one is if alpha beta both are positive, what is alpha into beta? Positive, that is c by a should be positive. This is condition for both the roots to be positive. Second situation is both the roots negative. Both the roots are negative. This means what? What d should be? Again greater than equal to 0. What should be sum of root? Both negative, sum should be negative. Minus b by a should be less than 0. And what should be product? Both negative, product will be positive. Negative into negative, positive. So c by a should be positive. This is condition for both the root to be negative. Third situation is one positive and one negative. One positive, one negative. What is the condition? D should be first, greater than 0, right? And then what can we say about sum of root? We cannot say anything. What can we say about c by a? That is product root. C by a should be less than 0. But when you see when c by a is less than 0, d is always positive. You try it. So this means if I just fix this one, d will automatically be positive, right? So this means condition is only one thing, that is c by a should be less than 0. Let's do one question on this. So how to solve it? We will write the condition for roots of opposite sign, then we will solve it. And what we know, roots of opposite side, only one condition, c by a should be less than 0 is sufficient. So what is c? That is 4a, and a is 1 should be less than 0. It's so easy question, right? This means a is less than 0, minus infinity to 0, that is your answer. The second part of the question is, both the roots are positive. How we will do it? Same way, we will write the condition and then simplify it. Both the roots positive, how we do that? First condition is d is greater than equal to 0. Second is minus b by a is positive. And then third is what? C by a positive. So what is d here? D is a minus 5 whole square b square minus 4 into 4a, that is greater than equal to. So it is a square minus 10a, and this is minus 16a plus 25. A square minus 26a plus 25 is greater than equal to 0. This is a minus 25 into a minus 1 greater than equal to 0. How to solve it? Using Sine scheme. So plot number line, critical point 1 and 25, plus minus plus. We are looking for greater than equal to 0. So this and this, minus infinity to 1 closed, union 25 close to infinity, right? Now solve second part, that is minus b by 2a. Second part is minus b by 2a is greater than 0. Minus b is a minus 5 divided by 2 is greater than. This means what? A is greater than 5. So it is 5 to infinity. Third is c by a is greater than 0. What is c? This means a is greater than 0, 0 to infinity. And then how we solve it? We need to find a which satisfies this and this and this. So how we'll do that? We'll take intersection. So take intersection. First is 1 and 25 outside. 1 included, 25 included. Then it says 0 to infinity. Third one. Second says 5 to infinity. 0 bubble, 0 to infinity, 5 bubble, right? Common is this. So answer is 25 infinity. So this is, I hope you understood everything what we did in today's class. I end today's class here only, and I'm adding some questions in the end. Please do it. Thank you everyone for watching this video. If you like this video, please like it, share it, comment on the comment section, and subscribe it.